All right, so what we're going to do today is we're going to look a little bit more deeply at what happens with points, what kind of lines they create, and how we can generate those lines using graphing software. Okay, so what I'd like you to do is I'd like you to put this table into Desmos. So I'll show you how to do that. When we go to Desmos, of course my smartboard doesn't want to work, so I'll do it over here. So when we go to Desmos, you have the option of putting equations in, which is what we did before, but you also have the option of creating tables. So notice this little plus sign up here. If you click on the plus sign and click table, it will give you a table. And the table that we're going to put in here, no problem, sorry. When we're up here, we hit the add item, and it gives us the ability to create tables. It gives us the ability to add folder, images, a note, some kind of expression. We've just done expressions thus far. Okay, so once you have a table up there, we're going to actually translate this data to that table. So at year 0, in this particular example, we have a copier that a company has purchased for $12,000. And over time, it's going to depreciate so that there's no value left in it after about 9 years. Okay? We got to change the table a little bit because it starts out with 1 instead of 0. Okay? So you're going to change your table, and you're going to have it actually have these for values. Try and do the Control C. See if I can copy this table and paste it in. Doesn't want me to. So year 0 is going to be $12,000. Year 1, $10,750. Don't worry about the dollar sign. 10,750 for year 1, year 2, 9,500. Year 3 will be 8,250. Year 4 will be 7,000. Year 5 will be 5,750. Year 6 is 4,500. Year 7 is 3,250. Year 8 is $2,000. And notice that nothing is showing up on my graph. Why is that? Any ideas? What type of numbers are we using? Big or little? Big numbers, right? So it makes sense that they're not going to show up when our graph looks like this with this scale. So what we have to do is we need to change our graph so that it is not using this big of a scale. Okay? Pause this. Depreciation of a copier, but similar. Yep, a car's going to do the same thing. Okay, so everybody see that we have very small numbers here, but very large numbers as far as the Y is concerned. So we're not seeing our values here. Over here in this wrench, it gives you the ability. I'm going to change it to projector mode first of all so that my numbers are bigger for you, but you don't have to do that. You're working off of your machine. but we're going to change our y values. Our x values are probably okay. We really don't need to go -10 though, do we? What number do we want to start with our x values? And x is, by the way, the time, the number of years that we're talking about. So how many years are we depreciating this copier? 8 years, from 0 to 8, right? So let's change our x axis to maybe have a -1 so we can see that y-axis, and then make the top number be 10. That way it fits our data better. And then we can change our step to say, I want to see every year. So you can change your step to have a 1 here. That way we get a 1, a 2, a 3, a 4, and so on. Now, our y values, we talked about it briefly when we put together our parent function foldable. Those are that's our range. So we're going to eventually have a copier that's worth nothing, but how much was it worth at the beginning? 12,000. So our range needs to be from roughly 0 to $12,000, right? Or maybe -10 to 12,000 so that we get our x-axis on here. So on your y values, we're going to go -10 and then 12,000 for our highest value, maybe 13,000 or 12,500. So we're sure we get that top point. And then it's going to automatically adjust our steps. Is by every 2,000 okay with everyone? That's what mine is already adjusted to. I think we're okay there. Is everybody cool with that? All right, so now we see a straight line depreciation. Why do they call it straight line depreciation? What do those points line up as? Yeah, a straight line. Okay, so they're considering that a straight line depreciation. So after 1 year, it's worth this much. After 2 years, it's worth this much. After 3 years, it's worth this much. And each time it's decreasing. So what is the slope of that line going to be, positive or negative? What do you say? Negative, yeah. It's going downward from left to right. Okay? This is decreasing in value as we move across time. So does anyone have an idea what our equation is going to look like? You told me it was a line. You told me it has a negative slope. So first of all, what is the equation? What is the pattern of the equation of a line? What does the parent function say? Y equals, yes, we did, mx plus b. So we need to have some kind of y equals mx plus b. So we're going to create a new function here. We're going to add an item called an expression. And we think that this is going to be something like y equals mx plus b. And you told me that m is negative, right? So negative something times x plus b. So does anybody know what our b is? What does b stand for in our y equals mx plus b? The y-intercept. Where does it intersect the y-axis? Can someone tell me where that points, the line is going to intercept or touch the y-axis? What is it? 12,000. Sorry you said it. I didn't hear you. I heard a mumble. All right, so we've got 12,000. Okay, so now we have to figure out what number are we going to put in front of x in order to make it slide down in this manner. So how much do you think it's depreciating every year, roughly? Just a ballpark number. We'll plug a number in and see if it matches our line. 2,000? 1,000? 3,000? What do you think? Throw a number out there. 2,000. Let's try 2,000. Okay. So we think it's a negative 2,000 x plus 1,200 as our first guess. Okay. What were we right? No, our line doesn't match our points, right? So we need to finesse something a little bit. I think we're okay on the 12,000, right? Because we're right there at that dot. So we want to make our slope less steep or more steep? Less steep, okay? So 2,000 is too big. So what should we try next? Let's try 1,250. Oops, that one's supposed to stay. Aha! How did you get that? Good. We said we are how much each time? From 2,000 to 3,250 is 1,250. From 3,250 plus 1,250 gets us 4,500. Does everyone see how we get this line? Okay, and that's called straight line depreciation. So its equation is y equals negative 1,250x plus 12,000. So if they give you another straight line depreciation type of problem, how do we attack that if we don't have Desmos to help us plot the points? Because it's going to take time to get on an iPad or a phone, get to Desmos, put those numbers in to the table, then start plugging in values for M and B. Does anybody have a strategy? How can we figure out what B is? In your table, which one is B? The time when the value of y when x is 0, right? Okay. So if they give you a table and they tell you at this original time, when we're starting out, this is our value, okay, then we're in good shape. Everybody good with that? So there's our b. We've got half of our equation. Y equals something x plus whatever it is at time 0. Okay? Now, how do we find m? M stands for the slope. How do we find the slope? Rise over run. How much is it rising over run? And which values stand for the rise when we're looking at a table? Rise is how much is going up or down. So is that the x's or the y's? The y's. The run is how much it is moving side to side. So that's the x's. So I could pick easy, right? And say in this 1 year, that's my change in x, I have a total of 3,250 minus 2,000, correct? And that's where we get our slope. Could someone have said, I want to know what happened in these 2 years? And I'm going to take a total of 5750 minus 8250. Yeah, we'll just have a bigger number. But it doesn't matter what 2 points you use, we'll always get the same slope when we reduce it because this is a depreciation of a linear nature. Does that make sense to everybody? So someone else could have said, I'm going to look at these 2 numbers and find the difference of them. But it's common and natural to want to deal with smaller numbers if possible, because we can do those mentally easier without having to borrow and carry. Okay, everybody good with that? All right, so the next thing that we want to do is we want to go to the next slide and talk about this table, just because it's data that I have readily available. It's a table that I have readily available. Okay, so this table comes from the U.S. Department of Agriculture. The government keeps track of crazy amounts of data over time through census, through the farm bills that they have, through you name it. They keep track of stuff. They know how many acres of wheat were planted in 1957. They know how many bushels of corn on average were yielded in 1963. Okay, they've just got this data and these statistics, and they know how much of this was exported to other countries and how much of it was used internally, and they have an estimate of how much of it spoiled and wasn't even consumed by humans or by animals. Okay, so here's our table, and what I would like you to do is I would like you to pick any of these, one row, whether you want to plot the total caloric sweeteners, or the cane and beet sugar, or the corn sweeteners, or the high fructose corn syrup, other caloric sweeteners. I think the top three are probably the most interesting as far as data is concerned. Okay, and we're going to make it bigger somehow. Let me do a zoom. Let's go 200% and see if that helps. All right, can everyone see the data now? Hopefully. Okay, so new Desmos graph. You can actually just stay in Desmos and click on the X beside the other ones that you already had in place. So I can say I don't want these anymore, and they're going to go away. Yeah, I knew that. Thank you. It's supposed to work anyway. All right, the magical way of doing this. Okay, so a new table, right? Okay, and here's our data. So our first year was 55, and we're looking at 109.6. Our next year is 65. Put my years in here really quick. It'll be faster. 75, 85, 95. So 114.4, 123.7, 126.5, and 145.9. How do we adjust our graph now? Be in projector mode so you can see. What do we need for our x-axis? Our domain. What years are we looking at? 55 to 95. So we need to make sure that we have 55 here and 95. So let's put 50 to 100. Is everyone okay with that? How about y-axis? What's my range? So can we use 100 to 150? Is everyone okay with that? Okay. So y-axis, we're looking at 100 to 150. And again, we can change our steps to adjust accordingly, but I think that looks pretty decent. Now, unlike the straight line depreciation, is this following a perfect straight line? No. And that's okay. This is real data. Okay, this is, and straight line depreciation is as well, but if we looked at a car's value, it's going to be a little bit more curved to begin with. It's going to fall more at the very beginning because it's worth less money, depreciates faster when you first buy it than a little bit later. So it won't be an exact straight line, but people use that for tax purposes and calculation of their assets. Okay, so we don't know what B is here, do we? At time 0, how much sugar did we consume? How much added sugar did we consume? We don't know, right? At time 0 doesn't even make sense. Okay, was that the time 0 when the government started recording this data, or time 0 way back when? Do we know anything about it though? Can you tell me what kind of slope this line has? Positive slope. It's rising. So we know we have a y equals mx plus b where m is positive of some nature. And we could do some subtracting here, right, to get an estimate of our slope. Okay, so we think that here in these 10 years, we've increased by about 5 pounds a year, roughly. Everybody good with that? Okay. In these 10 years, we've increased by about 10 pounds a year, correct? In these 10 years, we've increased by only 3 pounds a year. And in these 10 years, we've increased by almost 20 pounds. So I would say our slope is going to be somewhere between 3 and 20 based on this data. Does that make sense? Okay, so let's just try an equation and see if we can even get close. So we're going to say that y equals 3x plus, what do you think? Let's do this. Let's do y equals m, or yeah, 3. Not sure how the slider works. Okay, that's not going to work. X I think we have to what's that? Plus b. There we go, add a slider. Okay. And I think we want to do an m here too. And add a slider. There we go. All right, let me do that again so you can see. So I'm going to get rid of my sliders. And let me erase this real quick. The sliders can help us because then we don't have to plug numbers in. It allows them to slide. So we're going to add a new expression. And you're going to say y equals mx. And notice it gives you add slider m. Click on that button. And then we're going to do a plus b. And it says add slider b, so press that button. And we thought that our m was somewhere around 3 to 20, right? You see that our line's getting ready to pop in there now? So somewhere around 1.7 maybe. Let's look at b. Not quite getting it steep enough, are we? So we get to play with this. And b's not going to cooperate enough, I don't think. So sometimes there's a limitation to the B's and the sliders. So our next equation that we're going to put in here, though, is going to be what's called a linear regression. And a linear regression says, hey, calculator, I want you to tell me what the equation of this line is. Okay? We do that by using the tilde on your keyboard. So we're going to say y 1, so we're going to use the data, is approximately equal to m times x1 plus b. And we say, give me that equation. So I did y, and then I typed a 1, and it made it a sub 1, meaning use the data here in this table where y sub 1 is. Then I use the tilde sign, which is above, well, I'm not sure where it's at on your keyboard, above the tab on my keyboard. And then we put an m in there, saying we have some number we want you to calculate for us, and then times this x sub 1, which is our x values in the table, plus some letter b. So it's calculating our m and our b for us, and notice it has a r squared equals and an e sub 1. So we're going to plot those residuals. And did you get it to work? Oh, yep, to change the range. Yep. So you can do this if you change the range on this guy to be from 0 to 100 or 150. And then you can adjust it so that it gives it the right steepness. Let's see what this looks like if I zoom out. I should have an orange graph here somewhere. Bless you. All right, so there it is. Somehow I must have this one about right. Okay. So there's my line. Does that make sense? Then if it's difficult, crazy numbers, or a little bit, you can play with it and finesse it and figure out what m is and what b is and kind of slide and so forth. But it says that my slope is 0.8 and my b is 60. Pretty cool with that? So my equation is y equals 0.8x plus 60. So what does that mean? What is the 0.8? The m, the slope, right? And in real world, that means that for every year, we're consuming how much more sugar? 0.8, almost a whole pound of sugar every year. We have a sweet tooth. That sweet tooth helped us evolve to be able to survive. We like things that are sweet, and that helps us get calories and so forth. But we have so much sweet now available to us that we just keep adding to that sweet tooth and keep eating more, and it's not a good thing overall. What was that plus 60 then? Good. It's where the line intersects this y-axis. So we started out with our time 55 being 109. So basically they're saying at time 60, and again, these aren't great numbers to start with, but at time 60 is where we weren't adding any additional calories from added sugar. We were just getting it from fruits and vegetables and the other kinds of, the non-processed things. Okay, everybody good with this? All right, so let's make sure we get our iPads cleaned up and put back into the cabinet where they came from. 1 second, I'll stop recording.